I'm doing some factoring of polynomials.
Okay.
So, yeah, I understand some of it, but some of it's kind of iffy for me. But, let me give you the first one?
Sure.
Okay. It's going to be 2x squared plus 4x minus 16.
What's the first thing we should do?
Okay, so should we take the 2x and distribute it, because it's the greatest common factor?
Well, we want to factor out the greatest common factor always as a first step.
Okay.
What's the greatest common factor?
Just 2.
Okay, let's take it out. What's left behind?
It's going to be x squared. And it's going to be plus 2x. And then it's going to be minus 8. Right?
Okay. Now we have a polynomial that's much easier to factor. Whenever you can get the x squared to have a 1 in front of it instead of a number, it's 5 times easier to factor. Okay? So there's really 2 types of factoring problems. There's one where you have a number in front of the x squared that can't be factored out, and there's ones like this where there's a number in front of the x squared, but we can factor it out, and that makes all the difference in the world. So we'll leave that there, and now we're going to factor this. It's the first step in factoring that middle, or the part that's in the parentheses.
So when we put the x in the beginning of both of them, and then would it be a plus and a plus, or a plus and a minus?
It's got to be opposite. You cannot produce a minus 8 unless it's opposite signs.
Okay.
Notice that if I had plus plus, this would have to be plus. If I had minus minus, this would have to be plus. So when you see a negative sign on the constant, it means your signs have to be opposite. It's the only way you're going to be able to get that. Okay, and then finally the third rule is factors of 8 that do what?
Add or subtract to get to 2?
Well, subtract because of that same minus.
Would it be a 4, like a plus 4 and a minus 2 then?
Yeah. The 2 factors are definitely 2 and 4. Those 2 numbers subtract to the number 2. And we put the bigger of those factors, the 4, with the sign of the middle term. So the 4 goes right there because the sign on the middle term is a plus.
Okay.
So the 2 goes there. Now check it. Always check it by multiplying the insides and the outsides. The only term I'm checking is the middle term. You get the middle term by multiplying the insides and the outsides and adding them together.
Okay, positive 2x.
That's correct. That's the middle term. We've done it properly.
Awesome.
Okay, what else you got?
Okay, this one is 3x squared minus 6x minus 24.
Minus 6x?
Yes.
First step?
Okay, so you distribute the, or find the factor out the greatest common factor.
Which is?
3.
Leaving?
It's going to leave x squared. It's going to be a minus 2x. And then a minus 8.
Okay. Very similar to the last problem. What are the signs?
They're both going to be positive and negative.
They're going to be opposite.
Right.
Okay. And now we're looking for factors of 8 that subtract to the number 2. Again, 2 and 4. Only this time the 4 goes with which sign?
The 4 is going to go with the negative.
Yeah, because the sign on the middle term is negative. So we put the larger factor with the negative. And now notice that when we do our check, we get plus 2x minus 4x gives us minus 2x as a middle term. And that's the only term you ever really need to check. We know the way you factor these things. We know that x times x equals x squared, and we know that 2 times 4 equals 8. So we're pretty confident of those going in. It's the middle term that's always in question. Okay, what else?
Okay, it's going to be negative 9x squared.
Negative 1 or 9?
9.
9?
Yes. Plus 31x plus 20.
Is there a greatest common factor?
No.
Okay. So that's going to make this hard.
Okay.
The next easiest thing we can do is make sure we have a positive coefficient in front of the x squared instead of a negative coefficient. You never want to have a negative coefficient in front of the x squared. So how can I turn that positive?
Negative 1.
Okay, so let's take out a negative 1, leaving 9x squared minus 31x minus 20. Now, this is a lot harder to factor merely because there's so many more combinations. There's lots of combinations of factors for 9, well, there's 9 and 1 and 3 and 3, but there's lots of factors for 20 also. So where are we going to begin?
Be the 9, right?
What's that?
The 9?
Well, we got to factor that. In other words, I've got to split the x's up. How am I going to do it? Am I going to do 9x here and x over here? Or am I going to do 3x and 3x?
3x and 3x.
I always start with the factors that are closest together. And 3 and 3 are much closer than 9 and 1. Okay? Now, what are the signs going to be?
Positive and negative.
And again, it doesn't matter whether I go positive and negative and positive. It doesn't matter as long as these coefficients are the same. If these coefficients are different, then it matters, and you have to account for both possibilities. But in this case, and now I need factors of 20, and I can say nothing else. I can't say factors of 20 that subtract to the number 31. I can't say factors of 20 that add to 31. I can only say factors of 20.
Okay.
Okay? So let's list the factors of 20.
Okay. It's 1 and 20. And then 2 and 10. And then, let's see, 4 and 5. And then, yeah, that's it, right?
Yeah. So, clearly if I put 1 and 20, the 20 times the 3x is 60. We're never going to get to 31. So, we're not going to try that one. Let's try 2 and 10. Well, that gives us minus 30x, but then plus 6x. So that doesn't work either. So the only other possibility is the 4 and the 5. That's not going to work, right?
Right.
So we've exhausted all of the factors of 20. So now let's go back and try 9x and 1x. What works here? 2 and 10 doesn't work. 4 and 5 might. Yeah, 4 over here and 5 there works. Notice that it gives us plus 5x there, minus 36x there, for a net minus 31x. Okay?
Okay.
So that's correct. And let me make one further statement. This will be the hardest factoring problem you ever have to do.
Okay. If you have a negative.
There's all kinds of things that are hard about this. And I mean that. This is one of the hardest factoring problems I've ever seen any algebra student given, whether they're taking Algebra 1 or 2. Okay? There's 2 things that are particularly hard about this problem. 3 things. First of all, it starts with a negative sign in front of the x squared. So you got to get rid of that. Second of all, there's a number in front of the x squared even after you get rid of the minus sign. And this factors in 2 different ways. Thirdly, 20 factors in 3 different ways. So there's 2 possible combinations of this, there's 3 possible combinations of that, and the only really way to do it is to try all of them. And you get kind of good after a while. You'll notice it didn't take me a long time to figure out 5 and 4, but it was a trial and error process. In my mind, I was trying 1 and 20. I could see that wasn't going to get anywhere. I tried 2 and 10. That wasn't going to get anywhere. But when I saw the 4 and the 5, I realized, that's going to get us to 31. You're always trying to get to this number. If you can get to that number with the wrong sign, then you probably can just switch your numbers and you've got it. It depends. I shouldn't make a blanket statement like that. But this problem, I'm not even going to say this problem might have been easier to solve using your Diamond or California method. But maybe it would have been. But it wasn't that hard to solve using my method. And I guarantee you, you're not going to see anything tougher than this. Not if it actually factors. In other words, you might have something tougher than this that wouldn't factor. Change this to a 21, or let's say a 22, and now that thing doesn't factor nicely, and I've got to use the quadratic formula in order to come up with the answer. So that would be tougher. But in terms of problems that actually do have a factoring solution, this is as hard as it's going to get. Now watch you prove me wrong by giving me one that's harder. I hope not. But I don't think so. That's about as hard as I've seen.
I have one more negative problem. But
well, the negative doesn't necessarily make it harder, but go ahead. Because it's easy enough to factor out minus 1. What's hard is when you have a coefficient of the x squared that has lots of factoring combinations. Because then you have to deal with that many possibilities.
Right. This one's 3x squared minus 24x minus 144.
Now see, that's not hard because I can factor out a 3 of every term.
Right.
How do I know that's divisible by 3?
I don't know.
Because the digits add to 9. If the digits add to 9, it's divisible by 9, first of all. And if they add to a number that is divisible by 3, then it's divisible by 3. So since these add to 9 and that's divisible by 3, I know that 144 is divisible by 3. Let's talk about it being divisible by 9. Notice that your 9's tables are 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36. Each of these add to 9. 9 times 11 is 99. What does that add to? 18, which adds to 9.
Oh.
So if a number's digits add to something that is divisible by 9, then it's divisible by 9. And that's one way you can tell if a number is divisible by 9. To be divisible by 3 is even easier. It just has to be a number. In other words, the digits have to add to something that's divisible by 3. For example, 6. 6 is divisible by 3. What does the digits add to? 6. That's divisible by 3 also. Whereas 36 adds to 9. That has to be divisible by 3 also. 3. Because it adds to a number that is divisible by 3.
Oh, okay.
Okay? So that's kind of helpful. Another little helpful thing is numbers are divisible by 4 if the last 2 digits are divisible by 4.
Okay.
So 430 is not divisible by 4 because 30 is not divisible by 4. But 416 is. So a little bit of number theory that's helpful every now and then as to whether numbers are divisible by 3, 4, or 9. Okay, so we know that each of these is divisible by 3. Let's take out a 3 and see what we got left.
Okay. Okay, if you divide out the 3, you're going to get, it has to be x squared. And it's going to be, let's see, it's going to have to be a minus 8, right? And then a minus, what would that be?
46.
46.
Okay. So now we have a simple factoring problem. And it's simple because the x squared term does not have a coefficient in front of it, which means it's relatively easy to break down. What's next?
We're going to take the x, oh, sorry, my bad. Do a plus and a minus symbol.
Yeah, and the fact that it was x squared to begin with means that it doesn't matter if I put my plus here and my minus there or vice versa. That also makes it easier. Okay, now what's the final step?
Find factors of 46 that equal add or
No,
subtract, sorry, my bad, subtract to 8.
just to the number 8. Don't worry about the signs. We just want factors of 46 that subtract to 8.
Four and 12 work?
No? I don't know that there are any other factors of 46. You sure? Did I do 46 right? No, I didn't. It's 48. In other words, 3 into 144 is 48. Now, factors of 48 that subtract to 8. Let's look at those. Now, did I show you how to get factors, or what are the factors of 48? List them for me.
Okay, 2 and 24. That's not divisible by 3, is it?
Well, let's just keep cutting this in half and keep doubling that.
Okay.
As long as I can, I'm going to do that.
1, 12, and 4 work?
In other words, I've taken it all the way down and I've gotten all the factors. Notice that each one I just cut in half. And as I cut the left side in half, I doubled the right side.
Okay.
And now I have all the factors. Which of those factors subtract to 8?
12 and, 12 and 4.
Where's the 12 go? Where's the 4 go?
12 is going to go next to the negative symbol, and the 4 is going to go to the positive symbol.
These problems are a piece of cake when it's a 1 in front of the x squared. As long as they factor, they're pieces of cake. obviously if I make that a 47, I've got to use the quadratic formula to factor it. In other words, I won't be able to factor it, and the only way to solve it is by plugging it into the quadratic. Have you had that yet?
Yeah, a little bit.
Okay, good.
Okay, the next one is 2x squared plus 26x plus 80.
First step?
You're going to just, 2 goes into 26 and 80. So it's going to be 2.
You keep saying distribute.
Not bad. It's the
We're factoring out a 2 is the way to verbalize it. Okay? And when I say factoring out a 2, what that means is I'm going to go through and divide every term by 2. And what is left, I put in the parentheses. Okay? Now, another piece of cake. What are my signs?
Oh, it's going to be positive. Or positive.
Plus, plus. Now what do I...
How,
Go ahead.
sorry, how would you know if it's 2 negatives or not?
If the middle term was negative,
Huh?
then it would have to be negative, negative.
Okay, but if both terms are... Well,
Both
the
terms are
last
positive,
one is
right.
negative.
In other words, you always
Okay.
examine this first, and that tells you what your signs are going to be.
Okay.
Well, it doesn't tell you by itself. When you see a plus, it means the signs have to be the same.
Okay.
Whether they're negative or positive depends on the sign of the middle term. So as long as the middle term is positive and the last term is positive, it's always going to be plus plus.
Okay.
Now we want factors of 40 that do what?
Add up to 13.
Right. Add up because of that. Not because of this, but because of this. In fact, that could be negative, and we would still want them to add up to 13. Okay, what factors of 40 add to 13?
Let's see. 2 and 20, 4 and 10. I don't know. Is it divisible? It's not divisible by 3. I don't think.
Hold on. Let's go through the process you're doing. 40 and 1. What was the next one? 20 and 2. Notice I cut 40 in half and I doubled 1. Keep doing that.
Okay. So 10 and 4.
Keep doing it.
Okay. 5 and 8.
Ah. I
Oh.
can't cut 5 in half anymore.
Because if you do
Well,
8, there has to be 5.
yeah, I only do that as long as it is a whole number. Okay? Once I get down to 5 and 8, I'm done, essentially. Now, does it always work? In other words, 5 and 8 is the answer here, right? Those are factors of 40 that add to 13. Let's see if it works for everything. If I said factors of 30, well, the first step I would do would be to cut that in half and double that. Now I can't cut this in half anymore. So I somehow need to find that 2 factors, and I can't really do it using that technique I was describing. So sometimes, instead of cutting in half, you can cut in fifths. I'll take this and take 1/5 of it, which is 3, multiply this by 5, that's 10, and I come up with it like that. So you don't always have to cut it in half. Sometimes you can cut it by 1/3. In fact, I did. I missed some factors here. If I cut this in 1/3, becomes 5, which means I have to triple that. So there was a set of factors I didn't see the first time through. Okay? So factoring is a little bit tricky to make sure you find all the factors, but usually you don't have to look very far because you know you're looking for factors that have to add to 13. So as soon as you find those, you stop your search.
Okay. Okay, the next one, 6x squared minus 19x minus 36.
Tough or easy?
Easy.
Why?
Because everything's divisible by 6, and it's a
Did
positive.
you say 19 or 18?
So 19.
19 is correct?
Yeah. Oh, wait, no, my bad. It's not divisible.
Right. So hard problem or easy problem?
Harder.
Much harder. 6 has 3 different sets of factors.
Mm-hmm.
Excuse me, 2 different sets of factors. And 36 has a bunch.
Mm-hmm.
And we can't take any greatest common factor out, so this is going to be a massive trial and error. Where should we start?
Let's see. Would we take the 6x?
We've got to split it up. Split it up
Okay.
now.
Would you square root it then?
Not square root it, factor it.
Okay, so would it be 3x and 3x?
3x and 2x.
Oh,
In other words, however we factor it, it has to multiply back together to give you 6x squared. That's always the key, and you should always check that when you're doing these. As you do it, you should check it. In other words, don't wait till you get to the end, because the rest of the problem is predicated on the fact that this times this is equal to 6x squared. So if we make a mistake, we don't want to wait until the end of the problem to find out. We want to check as we go along. What are my signs? And this might be 6x and x. I don't know yet. But what are the signs?
Positive and negative.
Well, in this case, because these coefficients are different, plus minus is not necessarily going to be the same thing as minus plus. So I allow for both of them by writing it this way. Okay? Now, factors, again, we can only say factors of 36, right? Well, let's list them. Notice how I got that last one. I divided that by 3, multiplied that by 3.
I really like that.
And there's also, now I double this one and cut this one in half.
Okay.
So I got all of them, I think. Now, which ones to start with?
Let's see. Probably the 6 and 6, right?
Yeah, there's a problem. If I do 6 and 6, notice the signs are opposite. So the 6 times the 2 is going to offset the 3 times the 6. So there's no way we're getting to 19.
So you want to do the ones that are furthest apart then?
I would do one, I would try, yeah, I'm not going to waste my time with the 6 and the 6 because I can see I'm never going to get to 19, regardless whether I put 6 down here and 6 over there. So
3 and 12 maybe?
let's have a look at 9 and 4.
Okay, 9 and 4.
Those are the next two that are closest together.
Okay.
That shows promise because the outside gets to minus 27x, and the inside is plus 8x.
Which goes to
19x. So there's our answer.
Okay.
And as all we do is erase the other sign that I wrote. I don't have to check any of the other terms. I know that these two multiply to 6x squared, and I know that 4 times 9 multiplies to 36. So even though this was potentially a really hard problem, it turned out not to be that hard. You just kind of you go through a method. And you always start with the factors that are closest together, and then you broaden it from there.
Okay. Okay, the next one is negative 10x squared minus 34x minus 12.
What's the first thing I'm going to do?
Well, 10 cannot go into 34 and 12. And it's a negative, so you have to factor out the negative 1, right?
Well, 2 will at least go into every term.
Okay. So would you do a negative 2 then?
Right. Now,
Okay.
let me show you why I'm not going to try anything bigger than 2. Why I know that 2 is the biggest thing that is going to work. Because that's prime.
Okay.
I find, well, it's not because that's prime, because if this was like 25, I'd still be able to factor out another 5. It's really because that's prime.
Okay.
17 is prime. Since 17 is prime, there's clearly no other number that divides evenly into 17. Since it's prime,
Okay.
there's no number other than 17 and 1. So when you see a prime number in there, you know that the greatest common factor is 2, or minus 2 in this case. Now, this is not that hard because it looks like it could be hard, but there's not that many factors of 5. So this has to be 5x and x. And that helps because there's 2 different factors of 6. What are my signs?
What's 3 and 2? Oh, sorry, my plus and minus, and then minus and plus.
So we're going to start randomly with 3 and 2.
Okay.
What does that produce as a middle term?
Okay. Let's see. That's going to be 3x, and then it's going to be negative 10x, which is negative 7x.
Okay. Since 7 is not the same number as 17, let's say that it came up to be positive 17x.
Mm-hmm.
Well, then the only thing I have to do is move that 3 down to there and this 2 down to there. And it would give me a negative 17x. So the fact that this does not come up and even produce the correct number, in other words, it's not 17, means that there's no way 3 down here and 2 over here is going to work. There's no point in even trying it. So I might possibly try 2 there and 3 there, but I can see that doesn't give me minus 17x either.
Right.
So 3 and 2 aren't my numbers. 6 and 1 are, assuming it factors at all. So let's try 6 and 1.
Okay.
That doesn't work either.
So,
in other words, regardless, if I put the 6 over there, it's going to have to multiply, whether I put it with the negative or the plus, it multiplies the 5x, and I'm immediately at 30.
which is too high.
Much too high. So 6 and 1 doesn't work.
Okay, so
what's my alternative now? I've tried all combinations of 5x, and I've tried all combinations of 6.
Is there no answer?
There is an answer, but you have to use the quadratic formula. In other words, if you can't factor something, use the quadratic formula. Now, let's talk about using the quadratic formula for a moment. I could use the quadratic formula on just this part here, but it might actually be harder to understand the answer if I do that. So let's go back. Since we know it doesn't factor nicely, let's use the quadratic formula on the original thing. I don't have to. I could use it on the middle part, but it's actually going to be easier for you to understand if I use it on this part. Assuming that this is equal to 0, and I want to solve it by factoring, Well, I can't factor, but I know the quadratic formula tells me that the solution x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. What's a, what's b, and what's c?
A is your first term, B is your second term, and then C is your third term. So it's going to be negative 10x squared.
Just negative 10. These letters don't include the variable. They just include the coefficient.
Okay, so then negative 34 and negative 12.
Okay. Now we can plug these numbers into this thing.
Okay.
Let's do it. What's negative b?
Positive 34, right?
Uh-huh. Plus or minus 34 squared, negative 34 squared, but that's the same thing. In other words, it doesn't matter whether I'm squaring a negative or a positive number, I'm going to get the same answer. The rest of it does matter, the signs, though. Minus 4 times minus 10 times minus 12. There's a lot of minuses in there. All over minus 20. Okay? So now let's simplify this. So we get 34 plus or minus, do you have a calculator in front of you?
Yeah.
It's 34 squared. $34 times 34 should be near 1,000.
34 squared is 5.8.
Make sure you do 34 times 34.
So 34 times 34?
Uh-huh. That's what 34 squared is.
Okay. Yeah, 1,156.
Okay, now let's make sure we get our signs right. It's minus, well, this plus, or this minus times that minus is a plus. So I really have 40 times 12, which is 480, like that. All over minus 20. And I want to take this to the end just to show you why it was easier to do this way.
Okay.
So now I got to simplify more. What's that? That is the square root of 6, 7, 6 there. Excuse me. Let's see. I can't believe they gave you one this hard. I happen to know that this number is divisible by 4. Why?
Because 76
is divisible by 4. Exactly. So I can rewrite this as 4 times, let's see, 4 goes into there, what? 150 plus 4 goes into this 19 times, so that's 169. So that is 4 times 169. Did I do the math right there? Doesn't matter if I did or not. Even if I made a mistake, it doesn't matter. This 4 I can take out as a 2 now. You familiar with this process?
No, not at all.
Okay. I can do it because if I look at the square root of 4 times the square root of, say, 17, well, the square root of, excuse me, let me start over again. if I have 4 times the square root of 17 inside the radical, that's the same thing as the square root of 4 times the square root of 17. You can always separate them like that. And now the square root of 4, since that's a perfect square number, that's a 2. So this whole thing becomes 2 root 17. Okay? So that's how you simplify radicals. Now, that's why I was concerned that that number was divisible by 4, because 4 is a perfect square and it allows me to remove a 2. Actually, 169 is a perfect square. That's 13 times 13. So really, this is 26. 13 times 2. In other words, the square root of 676 is 26. You with me?
Okay. Yeah.
Now, what is our answer? Our answer is 30. Remember, this is what x is equal to. We started with a quadratic. We expect to find 2 solutions for x. Most of the time you find 2 solutions. Well, one solution would be 34 plus 26 divided by 20. Well, what's that? That's 3. And the other solution is 34 minus 26 divided by 20. Excuse me, the first solution was minus 3. The second solution is 34 minus 26, which is 8, divided by minus 20. That's 4/10 or 2/5, and it's a fraction. So my 2 solutions are x equals minus 3 or x equals 2/5. Now, if I go back to my original problem, this one right there, those are the solutions. X equal minus 3 or x equal 2/5. And I could plug either one of those in and you would see that that still remains an equation. In other words, it would work.
Okay.
Now, would it have been simpler had I factored out the 2 and then applied the quadratic? Actually, it actually would have been.
Really?
Well, notice that once I factor out the minus 2, I'm left with 5x squared plus 17x plus 6. Well, now my a is 5, my b is 17, and my c is 6. They're positive numbers. It's easier to deal with. I still have to solve that quadratic. And that's not going to give me the same answer. It's going to give me an answer divided by 2 because I've already taken a 2 out. So this one would give me minus x equal minus 1.5 or x equal plus 1.5 or minus 2/10, 1/5. Notice how it's harder to understand this answer. In other words, the answer to my problem is minus 3 and 2/5. If I factor out this greatest common factor first, and then I have to use the quadratic to solve this quadratic, which I would, I'm going to get solutions that are more difficult to understand than it would have been had I just used the quadratic formula on the original thing in the first place. Most of these calculations you're going to do with a calculator if you're dealing with big numbers. You know, if they're going to give you problems that have big coefficients like this, then they're going to let you use your calculator to solve it, but you still have to know how to put it into the quadratic.
Right.
But this principle as to whether you take out a greatest common factor first or not, I find it simpler to not do that. If I'm going to have to use a quadratic, I'm always going to apply it to the original function. Before I factor out a negative, before I factor out a 2, before I do any of that. I'm just going to start from there. For one thing, it's the simplest thing. I know that's A, that's B, and that's C.
Right.
So I can plug immediately into the quadratic to solve it and come up with a final answer. It is important to understand that when you're using the quadratic, it's x equals this. It's not just that. In other words, the solution to this equation is x equals those two solutions you would get. Because once you come up with those numbers, in other words, if I don't have x equals, I would have gotten to the end and I would have come up with those two numbers, -3 and 2/5. But what do I know? If I don't know that those are the answers, I wouldn't know to put the x in front like that. So always know that when you're using the quadratic formula, you have to use x equals the minus b plus or minus all of that. And it behooves you to memorize this. I know that that's a mouthful to memorize. A lot of teachers teach a little song to memorize it. I've been doing it for so long that I couldn't forget it if I tried. But most people have difficulty memorizing that. So just work on it. Sometimes you just have to memorize stuff by hook or crook. All right, what else you got?
Okay, 5x squared plus 21x.
I didn't catch the middle term.
Plus 21x plus 18.
Any greatest common factor?
No.
Okay. So now there's an interesting question. The question being is how much time do we spend trying to factor it before we give up and go to the quadratic? And I don't have an answer for that. I would at least try to factor this because there's only 2 factors of 5, and we're going to be able to exhaust all the factors fairly quickly. What are my signs?
It can be a positive and a positive.
Yeah, that's going to make it even easier. What are my factors of 18?
Sorry. Let's see. It's going to be 9 and 2. And then it's going to be, let's see.
Divide that by 3, multiply that by 3.
Oh, okay. So then you're going to get 3, and you're going to get 5, or 6, I'm sorry.
You think that's all of it?
Yes.
Okay. So, now, again, because this is a 5 and this is a 1, I cannot make any statements about factors of 18 that add to 21. I can't do that. That's why these are harder. Still going to try the closest numbers. Okay, I'm going to start with 3 and 6. Obviously, if I put 6 there, I got a problem, right?
Right, because you got 30.
I'm already at 30, and I'm not backing up. So let's try 3 there, and 6 there.
Okay.
Does that work?
It does.
We're done. So we didn't have to spend too much time. And if I would have assumed that it was not factorable and I plow right into the quadratic formula, I'd still be doing the calculations.
Okay.
Okay? So, in fact, that last one must have been factorable and I didn't see it.
Okay.
I must have erased it. But the one where we got -3 and 2/5 as answers, that means it was factorable. I must have done my calculations wrong. And I didn't see that one of those factors worked. Because notice that this one factors, and I'm still going to get fractions. In other words, if this is equal to 0, what's x equal
to? 0.
No, hold on. If this times that is equal to 0, how do I solve for x?
You would divide the 2 by 2 and then the negative 9 by 2, right?
No, you'd set each of these things in parentheses to 0. In other words, one of the most fundamental principles of algebra is if you multiply two things together and you get 0, then one of those two things has to be 0. You can't multiply any two numbers together and get 0 unless one of them is 0. There are no two numbers that will multiply to give you 0. So, once I get to this step, I can now say, well, 3x plus 4 is equal to 0, or 2x minus 9 is equal to 0. Solve each equation individually. This becomes x equals minus 4/3. Notice it's a fraction. And this becomes x equals 9/2. That's a fraction. So here's our solutions. So just having fractional solutions doesn't mean that it wasn't factorable. This one was factorable, and we still got fractional solutions. And the other problem, I ended up, after going into the quadratic, I ended up with a 3 or a minus 3 and a plus 5 2/5, which means it was factorable. I just didn't see it. I didn't need to use the quadratic. If I'd have played around with some of those combinations a little more, I'd have seen that it did factor. And that makes sense, because that's a little hard degree of difficulty if they're giving you those kind of problems that don't factor and that force you to use the quadratic. It sounds like you've barely learned the quadratic. Well, they're not going to give you big numbers if you've barely learned the quadratic. They may make you use the quadratic, but they'll make you use it with smaller numbers.
Okay.
Got 5 minutes. Time for one more, maybe.
Okay. Well, I have a different problem.
Okay.
It's on factoring polynomials.
Okay.
But it says find the x-coordinates, so the points where the graph crosses the x-axis.
Okay.
While you can use the graphs to double check your answers, be sure to show your algebraic work in order to receive full credit.
Okay. What's the function?
Okay. It says y equals x cubed minus 81x.
Okay. Now, when they say find the x-intercepts, if I were to graph a function, there's an x-intercept, there's an x-intercept, there's an x-intercept.
Okay.
What is true of y in all three of those cases?
They're all 0.
Aha. So that's how I do it. I set y equal to 0 and solve the equation. That will give me my x-intercepts. Now, what's the first step in solving that equation?
You have to factor x.
Okay, I can take an x. I'm going to put everything on the left just because we're more comfortable over here. Don't have to, but... Okay. Now, what about the x squared minus 81? Can I factor that?
Yes.
Why? What is that called?
I don't know. Oh, isn't it called difference between two squares?
Difference of perfect squares, yes. Because x squared is a perfect square and 81 is a perfect square. So it always factors into a minus b times a plus b. Or in this case, x minus 9 times x plus 9. In other words, you always take the square root of that for a and the square root of that for b. But in terms of a squared minus b squared always factors into a minus b times a plus b. If you have something that's more complicated than a squared minus b squared, you just have to figure out what the a and the b are. Like this one. The b is 9, and the a is x. Okay? So now I got all three of those things are multiplied together equaling 0. Remember, I started with a cubic. I would expect 3 solutions. That's the way polynomials work. If you have a quadratic, you get 2 solutions. If you have a cubic, you get 3 solutions. If you have a quartic, you get 4 solutions. So I'm expecting 3 zeros. 3 places on the x-axis where it crosses the x-axis.
Okay.
What are those 3 places?
This is -9, 0, and 8. Or, sorry, and 9, my bad.
I knew what you meant. And that's the way you do it.
Okay.
When they say find the x-intercepts of a polynomial, just set that polynomial equal to 0, and that finds the intercepts. All right, that's probably a good place to stop.
Awesome. Thank you very much.
You're welcome. I'll talk to you next time, Connor.
Okay. Take care.